Algebra 1, section 7.2. So section 7.2, multiplying polynomials. Multiplying polynomials. Okay, make sure you guys take notes and include everything I have on here to upload and get full credit. Should also include your name, today's date, what period you're in, just some obvious information. Okay, so let's see. We're going to learn 3 different ways to multiply polynomials, and you sometimes might be asked to use a specific way in your work to get credit, but really they all do the same thing. So eventually, probably after the section, whenever you encounter this in the future, you can use the method you prefer. I'll probably tell you which ones I prefer myself, which ones I think are easier, more convenient. But we're going to do a few examples to demonstrate how to do these. So example 1, the directions would be multiply using the distributive property. Distributive property. It's good to write this down because then you have this as reference as to what the style of work we're going to do right now is called. So when you see that in directions, you'll know what they're asking you to do. Okay, feel free to pause the video at any point to get caught up and write things down. Okay, so x plus 2 times x plus 5. So these are each polynomials. Specifically, they're binomials, 2-term polynomials. And they're in parentheses, and there's no symbol in between, but that should indicate multiplication. And what we're going to do, distributive property says that if you're multiplying some parentheses, that you need to multiply everything that's on the outside into each term on the inside. But we have multiple terms. So we're going to take x and we're going to multiply it times x, and then we're going to multiply it times 5. And we're going to write down what we get. We're going to get x times x is x squared. Remember the rules of exponents say you would add the exponents in that situation. It's an x to the first, an x to the first. X times x is x squared. X times 5 is plus 5x. Then we would distribute this. Now we got to distribute this term to all those terms. So the 2 times the x is 2x, and the 2 times the 5 is 10. Okay. Now I got to say this is probably my favorite method of all the methods I'm going to show you, and the most, but I'll show you some other ones. Now we want to clean this up. We want to combine like terms. So we can only combine things that are like each other that have the same variables with the same powers. So 5x and 2x are like each other. So your answer is going to be x squared. Now 5x plus 2x is 7x, not x squared. We don't add the exponents, okay? We're counting like objects. I have 5 of these, I have 2 of these, I have 7 altogether, but the object shouldn't change in your answer. I have 5 apples and 2 apples, so I have 7 apples. I don't suddenly say I have 7 oranges. Plus 10, this is also called standard form, highest power down lowest power. It's nice looking, it's clean. Now we can multiply unlike terms. That's what we're doing, but we can't add or subtract unlike terms. So that's called the distributive property. Let's do another example using a different approach. So example 2, the directions will say multiply using a table. And so we'll write another problem here, 2x minus 3, parentheses, x plus 5. So we're trying to accomplish the same thing we did in the last problem, but we're going to use a different approach. So this is kind of a more visual kind of organization. So what we do is we if we have two terms, we need three columns. Two terms, we need three rows. So we're going to make a grid, a table that has three columns and has three rows. Okay? And we're not going to use this spot. So what we're going to do is we're going to put each of these terms up here. It doesn't matter. I mean, I'm going to put them on the top and then put these on the side, but you could do it the other way and it should work out. But I'm going to put the 2x here, the minus 3 here. So the minus belongs to 3 as a negative. So I put these two terms there, and then I'm going to put these two terms over here, x and 5. Okay? Now what we're going to do is this is kind of like a multiplication table. We're going to multiply these two together to put right here. X times 2x is 2x squared. You add the exponents, right, when you multiply x times x, okay? And then we're going to multiply this times these. So I'm not going to usually draw these lines, but I'm just trying to do that to show you sort of the movement here. So that'd be a minus 3x. Then we're going to multiply those two together to put right here. That's going to be 10x. And we're going to multiply these, and that's going to be minus 15. And these are all your terms like we got right here. Now, one thing about this is these will probably be your like terms, right, that you can combine. And so what we get is we get 2x squared. We should put that one first, the highest power first. And then 10x and minus 3x is 7x's, just 7x. I got 10. I take away 3. I have 7 left over. Don't change the type of thing you're counting. And then I have a minus 15. And that's your answer. So, I mean, this is nice, but it does take some effort to set it up. And, you know, I don't know. I think in the future, you'll probably find that you could probably be quicker if you just do it the other one. Now, there is a third approach, but it's kind of specialized. It doesn't work in all situations, which is maybe a weakness of it. But multiply using FOIL. So like foil, like tinfoil. It's a tool to help make it easier to remember what these letters stand for, to remember them all. So F is for first. O is for outer. I is for inner. And L is for last. First, outer, inner, last. And then FOIL is a way to make it easy to remember. So let me show you an example using this approach. So first is talking about the first terms. So each of these binomials, this is binomial, this is binomial, each have a first term, and you want to multiply the first terms together. So that's what first is. And so you get x times x is x squared. And then you do outer. So this is, the outer is like the outside on both sides. These are both outside. This is on the left outside, this is on the right outside. So we get x and minus 6 is negative 6x, minus 6x. So that's outer. Now, inner is right here. Actually, I probably should have done outer up here. That's usually where you draw that line. Not that it makes a difference. So then this is inner. And so negative 3 times x, they're both on the inside, is minus 3x. And then lastly, we want to do last. Last term of the first binomial, last term of the second binomial is positive 18. Negative 3 times negative 6. Remember, these negatives belong to those numbers. And so now we have an answer that looks like, you know, what we got before. Of course, we want to clean it up. We want to combine like terms. And so your final answer will be x squared minus 9x plus 18. So that's FOIL. And it's just a cute word to help you remember to multiply everything. But if you look at this, we really just did the same work we do when we distribute. That's first, outer, inner, last. It's the exact same work. Do you need a cute nickname to remember to do that? I think it's actually easier to just be like, I'm going to distribute. Also, this only works if it's a two-term polynomial times a two-term, a binomial times binomial. If it doesn't, if it's not that, then you would have to come up with a whole new cute word that had 6 letters in it. So this next problem right here is a problem that we wouldn't be able to use that approach on. We could use the other two. Multiply a binomial and a trinomial. So as soon as you do that, this cute little technique that we did on example 3 goes out the window. And every other, special case would need its own special word. And we don't want to come up with special words for all those cases. We don't want to remember them. Like I said, really you just want to probably just do distribution. You could do the table, but the table takes a bit of work. So you could do this problem on the table. Now, this is a binomial, two-term polynomial, times a trinomial, three-term trinomial. And the way I would do it is I would just distribute. X times x squared is x cubed. X times minus 3x is minus 3x squared. X times minus 2 is minus 2x. So you got to distribute this to everything in the other one. And then you got to do this one times everything. Now, you could write it over here, plus 5x squared minus 15x minus 10. And then you'd want to start combining like terms. But so you could do this and then start combining them. Or when we start doing the second one, we could line them up underneath the terms they match up to. So when I do 5x squared, I'm like, oh, I'm going to put that right here, 5x squared. And then when I do minus 15x, I'm going to put that right here, minus 15x right underneath minus 2x because they're like each other. And then I get the minus 10, and I just put it over here. So you could do this or you could do that. It's up to you. I'm not going to really argue strongly for one or the other. I mean, I honestly probably do it the first way. Now, when you do it like this, you say, okay, x cubed plus 2x squared. Don't touch the exponents. We're just adding, counting them up. Minus 17x minus 10. So it's kind of nice that the like terms are right above and below each other if you do that stacked approach. But you could get the same answer this way. You'd say, okay, well, there's only 1x cubed. There's a minus 3x squared and plus 5x squared. So that's plus 2x squared. And a minus 2x and a minus 15x. Well, that's minus 17x. And then a minus 10. Now, I like to cross them off as I go so I don't mess up and get the answer like that. Now, the other thing we did, I think in the last section, was we decided to rewrite the whole thing so that these things were next to each other, and then we combined them. But that's a lot of extra work, too. Anyways, we get a four-term polynomial, which we don't really have a special name for four terms. This is a trinomial because it has three terms, right? And if they have two, it's a binomial. If it's one, it's a monomial. But at four and up, we don't really give them special names anymore. I guess you could call a four-term polynomial like a quadnomial or something, but people don't really do that. Okay, last example. Example 5. X plus 2 squared. Okay? Now, this is kind of a special case. And there is sort of a shortcut that I think I might show you next week. But honestly, I don't even think it's worth it. Okay? But we're going to just treat this problem like the problems we've been doing. Now, one of the things I want to make sure you know is not true is you cannot just distribute exponents. You can't say, oh, this is x squared plus 2 squared is 4. That is actually wrong for sure. So don't distribute exponents. Okay? There is a shortcut that works. I don't want to show it to you right now. I'll show it to you next week. But even after that, I don't know if I would do it because it's one more thing to memorize that I don't really think saves you that much time. What we should do is say that x plus 2 squared is x plus 2 times x plus 2 because that's what it means. If something's squared, it's that thing times the same thing. So we could just write it like that. And now this problem looks like all the problems we've been doing today. I would distribute, if I had a choice, x times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. Okay? I mean, we could just do that. That's just treat it like all these other problems. Now, of course, like terms, you combine together, x squared plus 4x plus 4. And that would be your answer. So that's the way I want you to do those kind of problems. If you run into something that has an exponent like that outside a polynomial, then you got to rewrite it like this. Okay, for today's in-class work, monitoring progress out of your textbook. It's on page 366, problems 1 through 10 all. You need to write your work down, problem numbers, write the problems down, show your work, write your answers, box your answers. I would use a student dynamic ebook online, to Big Ideas. And if you do that and you zoom out all the way, which might be a little inconvenient, but they have these little blue arrows next to each problem that you can press play on, and it plays a video showing you exactly how to do that problem. So there's no excuse not to get this done. Even if you get stuck, even if you don't know what you're doing, you can watch these videos and it'll help you figure them out. Try as best you can to do it on your own. You could also use the videos to just check your answers, even if you think you know how to do it. That's it.